Okay, welcome back, class. Today we're going to follow up on what we've learned with the ARM pipeline architecture, and we're going to talk about a important way of modifying the pipeline architecture to deal with some problems that come up with this fact that we are dealing with this parallel running of instructions. So the fact that we kind of taking stock in what we've learned so far, when we were looking at the single cycle architecture, there's no parallelism happening, right? We're running one instruction, then the next instruction, then the next instruction. And then we saw with the ARM pipeline, we're running five instructions simultaneously. And as you might imagine, there is actually some problems that come up when you have that level of parallelism happening, particularly with dependencies when one instruction depends on something happening in another instruction. That's what we're going to look at in this video. We're going to look at a particular way of dealing with one such problem called forwarding, and we will have subsequent videos to talk about some other problems that come up. Okay. So first, a couple definitions. What we're looking at when we run instructions in parallel, something can come up called a data hazard, and a data hazard is when we have one instruction that is modifying data that is used at a different stage in the pipeline. Okay, and we're going to look at an example of a type of data hazard that comes up in this video, and we're going to look at how we can actually fix it and remove the hazard. Okay, if we don't deal with data hazards, we have this problem, what's called a race condition, in which we have this idea when we have two operations that are trying to modify something or trying to use a resource at the same time. And this nature of we have one thing updating it before the other thing is being able to read it properly, or vice versa, right? We'll look at it. Race conditions are something that comes up a lot in computing, where we have this idea of we got basically two operations or two things that are trying to use the same underlying resource, and there's a timing issue that comes up in how they're used. Okay. Now, I think that's a little abstract so far. I think we have to do is we got to look at an example. When we look at an example, it's going to make a lot more sense. So let's take a look at this. Okay, let's take a look at this, and let's we've got these two instructions here, and let's assume that we're running both of them in the ARM pipeline. Okay, we've got the subtract operation followed by this add operation. Okay, and there is a dependency that comes up in which we are writing to register 1, okay, and the next instruction is actually reading from register 1. Okay? And so this asks a question. It says, well, when is, if we started running this program, let's assume that we start, that the first clock cycle is clock cycle 1, right? And we ask the question of what we've seen previously is, when is x1 updated? When is it written to? Right? So when, the question of when is x1 written to? Okay, when does it get the value of register 2 minus register 3? And the answer to that, okay, is clock cycle 5, because that happens at the write back stage. We're writing back to a register. So it's not written to until clock cycle 5, right? Stage 5. And then if we looked at that and we said, well, wait a minute. Here, and we said, when is x1 read? Okay, and it's going to be read at stage 2. Stage 2, so that would be clock cycle 3 because it's the second instruction. So that would be, so at stage 2, we are reading the instructions, right? We're reading the instructions at stage 2. And because of that, right, we've got this timing problem where we have the correct value being written at clock cycle 5, and we're gonna, if we don't do anything, we're gonna read the incorrect value at clock cycle 3, right? Because x1 will have the old value that was previously at that location. So is there a problem with running this code in the ARM pipeline? Well, without any modifications, there is, right? We've got this issue here in which we've got this timing issue going on, right? And sometimes people refer to this either a data hazard or can be referred to as structural hazard, in which the processor needs the same resource at the same time, right? Basically, we're trying to use the register file, okay, over multiple instructions at the same time, and we haven't updated it, right? The first instruction, the subtract instruction, hasn't updated it yet. It has not updated it yet, and then we've read it in the add instruction. Okay, so let's take this a little bit further, right? And we're going to look at it. The key thing we want to look at is we say, well, what's the solution to this? And we're going to modify our ARM pipeline architecture design to do something called forwarding. Sometimes people refer to it as bypassing. And this is a way of resolving a data hazard by allowing us to take the correct value and bring it back to an earlier stage in the pipeline to be able to avoid having that underlying inconsistency, to avoid that data hazard. Okay, let's look at how we're going to do that. Okay, so if we look at these two instructions here, right? If we look at these two instructions here, they're very similar to ones we just did, although now we have to add first and subtract second. And we look at that and we say, okay, if we've got this S1 is the dependency here, where we're writing to S1 in the add instruction, we're reading to it in the subtract instruction. And we think of, well, when is that correct value of S0 known? When is the correct value of S0 known? And if you think about it, right, that value is calculated, right, at the end of the execute stage, at the end of stage 3. By the time we get to the end of stage 3, the ALU has calculated the sum, right? The ALU has done the operation of register T0 plus T1 in this case, right? It knows the sum. It hasn't written it back to the register yet. That doesn't happen all the way until stage 5, but it is calculated. The value's there, okay? And if we have a way of taking that value, okay, taking that value and bringing it and sending it to the input of an earlier stage, okay? If we have a way of sending it to an earlier stage for the subtract instruction, if we have a way of sending it as the first input operand for the subtract instruction, we can remove the data hazard, okay? So if we make that connection there, where we have a way of taking the old output we take the output of the ALU from the earlier instruction and send it back, right, or forward it back to as an input for the following instruction, we can remove this data hazard, okay? So that's what we want to do. That's what we want for our design, okay? So another way to look at this, right, is this is a little bit of a more detailed example, and we've got this issue where we've got, in this case, x2, okay? x2 is being written to by the subtract instruction, okay, and is used, okay, it's used in the next multiple instructions after it, okay? We've got this dependency with register 2, okay? And what we're going to do is we want to have a connection here in which we could send the output we want to send that sum of register 1 and register 3. We want to send that as an input here to the ALU, to the first input operand in this AND instruction, okay? And, right, we also want to do that for the OR. The OR instruction, this instruction, if we have instruction 1, instruction 2, instruction 3, instruction 4, and instruction 5, right? Instruction 3 also has this timing issue, right? Because instruction 3 is, if we think about it, right, it needs that value, right? It needs the correct value of register 2. It needs that at stage 3, right? And that value is not written to if we didn't do anything, right, it needs the value at stage 3, but we've got this issue where the register for instruction 3 is being read, register 2 is being read by instruction 3 and it's stage 2, and that's at clock cycle 4, right? But it's not being written to the register until clock cycle 5. So we still have a timing issue, right? We still have a timing issue for instruction 3. However, right, as we've seen prior, it's kind of the same idea that if we connect a signal that goes from the output of stage 4 from instruction 1 and we send it as an input operand into the second input into the ALU and for instruction 3, we can remove that, we can remove that, that data hazard, okay? Now, instruction 4, there's actually no problem, right? We don't have to do anything for instruction 4. And the reason why is there's no longer a timing issue, okay? If you recall from an earlier video, the register is always written to in the first half of the clock cycle, the first half. And that's why we see this here where it's shaded, right, in the first half here. It's written to in the first half of the clock cycle, okay, and then it's read in the second half. So by the time we get to instruction 4, there is no data hazard that needs to be addressed, okay? The normal operation, the normal function and flow of the pipeline design that we've seen previously is totally fine, right? For the fact that we write to the register in the first half of the clock cycle and read it in the second half, okay? And then obviously the instruction 5, right, there's also no issue, right? By that point, the correct value is sitting there. It's sitting in the register. You just read it like normal. Okay, so it's really this problem comes up, this data hazard comes up if you write to a register and then read from it within 2 clock cycles of that register being written to. Okay, and we're going to use forwarding as a way of addressing it. We're going to use forwarding as our way of being able to fix this problem. Okay, now this might be a little bit confusing to thus far. Right, let's do a couple examples of first like detecting like, hey, when is forwarding happening? Right, when does it actually come into play? And what we want to do is we want to look at an actual diagram to say, okay, well, how is this actually going to work and trace out 1 or 2 things? Okay, so first, let's answer this question: does forwarding occur, and if so, where? Okay, what we are looking for here is we are looking for a register that is written to and then read within 2 clock cycles. So we have this register here, register 1, being written to, and it is being read within 2 clock cycles. Okay, so we have this dependency here. Okay, and we are going to need to forward to be able to remove that data hazard. Okay, that is actually not the only dependency. We also have this second issue where we have register 3 also being read within 2 clock cycles. So we have these 2 cases where forwarding is going to need to occur. Okay. All right. Let's take a look at another example here. It's a slightly different case. And what we're looking for, again, is are we writing to a register and reading from it within 2 clock cycles? And once again here we have register 1. Okay, we've got register 1, and in this case, the second instruction, there's no problem, right? There's no problem with the second instruction because it's not reading from register 1, okay? However, the third instruction is. The third instruction has this problem. Okay, so we're going to need to forward to deal with that. We're going to need to forward to deal with that. Okay? All right. Now, if we look at this one, right, I'm going to go ahead and just give you the answer. No forwarding is necessary in this case, right? Because this has to do with a similar thing I had mentioned previously, but we're kind of looking at it from a different angle, is if we have enough time, right? If we've got enough time going by here, in which we've got these 3 clock cycles difference, there's no longer a need to forward because register 1 is going to be written to at clock cycle 5, and it's going to be read at the second half of that clock cycle, right? So we can actually read and write from a single register in the same clock cycle. That is okay, right? And we know that they're both going to happen at clock cycle 5 because we know that this is going to happen at the write back stage, okay? stage 5, okay, and the read from register 1 is going to happen in the instruction decode stage, which is stage 2, okay. Okay, since that's instruction 4, it starts running at clock cycle 4, and then +1 because we're talking about the second stage. So this is where we know that they're both going to be in clock cycle 5, where one's writing to the register while the other's reading from it, from register 1. Okay, that's okay. All right, that's okay because we're going to write to it in the first half of the clock cycle and read from it in the second half. Okay, let's look at another example here. And this one's a bit longer, so let's be careful. What I'm going to do is I'm going to look at that first register 1, and I check, and I see that there is no place where register 1 for that first instruction. If we look at instruction 1, okay, look at instruction 1, and we see it's not being read anywhere in the next 2 instructions. Okay, then I'm going to look at that register 4 for instruction 2, and once again I don't see that read anywhere in the next 2 instructions. Okay, then I look at instruction 3 and I see that register 5 is being accessed within 2 clock cycles, so there is a dependency there. Okay, for instruction 4 I can see that register 6 is also being read. So there's a dependency there, okay? And then it looks like we got all of them. So we do have forwarding occurring, and there's the dependencies. So what we're doing here is we're identifying the dependencies first. We're saying, hey, where is this stuff happening, right? And that's kind of the first step. Okay. Now what I want to do here is I want us to start looking at the way in which we deal with this from a perspective of actually looking at the architecture diagram. Right, looking at the pipeline architecture diagram and saying, hey, how does this actually work? Right, how are we actually dealing with this stuff to be able to get it to deal with these dependencies? Okay, and so I want to bring your attention to this forwarding unit. This is notice it's in blue, indicating that it's a control unit, and we've got these 2 control signals that are going to control 2 multiplexers that are in the execute stage, stage 3 of the pipeline. Okay, we have what's labeled as A. That is often referred to as the control signal forward A. Okay, forward A, and then we have the control signal B, is often referred to as forward B. Okay, and what the control unit is doing, that forwarding unit is doing, is it's looking for the dependencies that we just kind of were drawing out here, right? It's looking for, are we writing to some register, and within 2 clock cycles are we reading from it, right? And if you actually look at the signals that are coming into the forwarding unit, you can see that the signals coming in there is enough information for it to detect those conditions. It's looking and trying to detect, hey, is there a conflict here? Is there a data hazard that we need to deal with do we need to be able to forward to be able to deal with that with an underlying data hazard? Okay, so let's look at this example here. We have these 3 instructions, and what we've got is we have this underlying case where we're going to have some dependencies where we have this dependency here, okay, and then we have this other dependency, okay, here. Okay, so we've got these 2 dependencies going on here, and they're both related to a problem that happens for instruction 3. So if we've got our instructions, we've got our instruction 1, instruction 2, instruction 3. We've got this issue that if we don't do something, instruction 3 is going to read 2 incorrect values out of the register file. So we've got to forward. And the forwarding unit's going to detect this scenario. Okay, it's going to detect this scenario, and it's going to deal with them appropriately. Okay. So what I want to do is, one of the first things I want to do is let's look at what happens. Let's take a look at this example, and particularly what I want to take a look at is what occurs here, and I want to trace this when instruction 3 okay, is in stage 3, which is the execute stage. Okay, and that's going to be at stage 3 at clock cycle 5, right? Because it's going to start running at clock cycle 3 and then 2 more. So let's look at this at clock cycle 5. We're taking a snapshot of this at clock cycle 5. Okay, at clock cycle 5. Now, one of the things I want to point out here is that at clock cycle 5, okay, if we kind of slice up the stages here, okay, we're going to have instruction 3 in the execute stage, okay, and we have instruction 2 in the mem stage and instruction 1 in the write back stage, okay. So that's why I'm looking at clock cycle 5 in particular, okay, is that's where kind of the action's happening where we need to forward. Okay, that's where the control signals for A and B are going to be a bit different. Okay. So let's look at what happens in that case, right? Now let's look at control signal A for the, which is the first input operand into the ALU. And what we want in that case is we want to get a particular value. Okay? And the value that we want is we want this value here. Let's see. We'll use a different color. We want this value here that had come as the bypass out, okay, of the ALU previously, right? This is going to be the value that is going to be written to, if we follow this line here, I gotta be careful I'm looking at the correct line. If we follow it, this is the same line that would eventually come up here and be written to the register, okay? However, we're not just going to write that at clock cycle 5 to the register. We're also going to take that signal here, and we're going to come up here, and we are going to select that, okay, to be what is our going into the ALU for instruction 3, okay? So because of that, if we assume that we look at these multiplexers and that each mux is going to have the 0, 1, and 2, or the like that, we're going to assume that 0, if the control signal 0, it's the first input, is going to be the output, 1 or 2. This here for the forward A, we want that value here to be 1. We want this to be 1 so that we select that red value to be what's going to come as our input into the ALU. If there's no forwarding, the value is going to be 0. Because it's going to take the previous, what was regularly read out of the registers, and use that. Okay? All right. Now, that handles the first input. That's for the dependency with register 0, because we needed to grab the value that was in stage 5 because there was 2 clock cycle difference. Right? Let's see what happens if we're going to use the other one, right? I'll choose a different color here. If we look at the if we look at the dependency with register 2, we want the one coming from instruction 2, which is currently in the mem stage, okay? And we want that value, which is going to come up here, okay? Like that, okay? So you think about it, instruction 1 was in the write back stage, so we wanted to grab the value that was in the write back stage, okay? Instruction 2 was in the mem stage. We're trying to grab the value. The dependency is getting the value that's currently in the mem stage, okay? And then if we look at what the architecture must do to support that, we know that control signal B here must be 2, and I'm going to write it as 1, 0. Okay. All right. So I think, okay. If you get that, if you understand that, I encourage you to rewatch it, first of all, and really trace through. Remember a couple key things, right? Think about where the information is, what stage in the pipeline it is that we want to access it, okay? As well as where it needs to go to have everything work correctly. So notice that register 0 was, the dependency relates to instruction 1, which is in the write back stage, okay? And it needs to go into the first input into the ALU for instruction 3, which is in the execute stage, okay? Instruction 2 is in the mem stage, stage 4, and that needs to go to instruction 3, which is in the execute stage, and it's going to be the second input into the ALU. If you know that, you could trace where things need to go and figure out what those control signals must be for this to work appropriately, okay? Takes some getting used to, right? We'll do some practice exercises to trace through this and give you a chance to ask questions, which I encourage you to do. And feel free to ask questions and to rewatch lots of times to let this all sink in. Stay happy and healthy, everybody, and I will talk to you soon.